So, welcome back to the rookie track. Hope everybody had a good lunch. Yeah, first up after lunch is Joe. Go for it. Clicker if you want to follow. Okay, hi guys, my name is Joe Greenwood and I'm going to give you a talk today on objective and game-based capture flags. So, who am I? If you really want, you can follow me on Twitter or go to my website, but you're probably here to talk rather than me. So more importantly, I'm an aerospace student at Bristol University, sponsored by the Royal Navy as a pilot. So the question you're asking now is why you're here in front of me. And I did the Cybersecurity Challenge UK a couple of years ago, for the past 3 years, and won a load of press-registered courses, SANS courses, all that sort of thing. Sort of got me into security as a hobby. So if you have a chance, do that, it's good. But today, what we're going to cover, what is a capture the flag competition? How can we improve capture the flag competitions, and how do we develop security teaching as a whole in professionals and also in students, university students? And hopefully, as I've written the slides, lots of pretty pictures and examples. So does anybody not know what a capture the flag competition is? Okay, well you're here because you read the title and thought that was interesting. So, okay, so capture the flag is lots of people staring very intently at computers, pretty much. There's two general types of capture the flag. So the first type is what's known as Jeopardy, where you have this lovely board of challenges and you pick a challenge from the list as a team, solve the challenge and you get a string as your flag as the answer. You give the flag back to the score server and it gives you some points depending on how hard it is. And then the team with the most points wins, basically. The other type is called Attack Defend, and this is more of a pen testing type network side. Every team has a computer or a network that they need to defend, whilst also attacking other teams' computers and networks. And generally, there's lots of really badly written services that you can exploit on their servers. You get a flag from that service, and then you give it to the score server again, and you get points. All good fun. So, why do we run them? Why are they useful? So, in university degrees specifically, there's little or no security at all. So, as an aerospace engineer, we did 20 hours of C programming in the first year, and that was it. That was programming for the 4 years done. When you think these are the people who are going to be writing the control code on aircraft as their jobs, that gets very scary very quickly. Computer science, you'd hope it'd be a bit better, but they're mostly higher level languages. You don't really get many computer science courses that teach low-level C or assembler, or the security aspects of that. So that's not good. Also, hands-on learning is good. It's good fun. And yeah, they're good fun. So we've said how good capture the flags are, but there's certain things they don't do very well. So post-exploitation, as you know from pen testing, is a really important part of it. You get access to the computer and then you do something with it. So there's nothing particularly special about root in getting root itself. It's that root allows you to do things. So there's often this impression that having a system compromised is a bad thing in commas. But honeypots, for instance, we want those to be compromised. So it's not a bad thing for that, because in a honeypot you can't do anything once you are root. Also, you have to think about why we're hacking into these things, other than for fun, of course. But there has to be a reason behind it, and capture the flags don't often give you that reason. So, as an engineer, I want to think what physical consequence happens if I hack this computer, or what information is lost if I hack into this computer. So think of poor engineers. So, I'm part of a group at the University of Bristol who designed and ran a capture the flag that did the whole CTF design process backwards, so to speak. And I'll explain what I mean by that. If anyone gets the reference, bonus points. So when you're designing a capture flag, typically, you decide what type you want to run, so Jeopardy or Attack Defend. Then you develop your back-end infrastructure for it, so you deploy your virtual machines, all that sort of stuff. You build some challenges to run on that infrastructure. You develop how you're going to score it, so whether you have a flag submission or whether you just automatically know that it's being compromised. Then you panic that you don't have enough challenges or that the scoring doesn't work. And then you run the CTF eventually. So that's the typical way it goes round. However, what we wanted to do was we started the post-exploitation. We said, what do we want to do at the end when you've got root? And we wanted something reasonably serious to happen if you did get root. We thought nuclear war was quite a good way of expressing that. So if anyone doesn't know, this is the game DEFCON, which is a thermonuclear warfare strategy game, where every team has a continent, or every player rather, has a continent. Every continent has a number of nuclear silos, radars, ships, submarines, all that sort of stuff. Then they move them around to wage thermonuclear war. If anyone's seen the film War Games, it's pretty much that, a game. And you can get all these alliances formed, or you can just nuke everybody. It's quite good fun. So we thought, how about doing this, but having a back end of cybersecurity on the end of it? So we started and said, we want to play DEF CON, as that's what we want to do. How are we going to score it? Population killed is quite a good one. So we had, every team was a continent, and they had a certain population, and depending on how many people they lost from that continent, that was negative scoring, obviously. As I said, this is an attack-defend capture the flag, so every team had a number of services, and we score them on the uptime of those services. So in a real business environment, you're trying to keep your services up for your customers or your air force, in this particular instance. So if you had services down, you'd get scored negatively. So red was not doing very good on that side. And then we built the challenges and the infrastructure around that. So this is a JSON file that was used by the silos, I think. So here we've got 3 Trident missiles in the air. And there was a back-end game, so we rewrote DEF CON in Python. That was fun. And that was controlled by JSON files on computers. So every team had a separate computer with controller programs that modified this JSON, and that was reflected in the game at the back end. So when you compromise a team, you could then run their nuke program, for instance, and tell it to nuke their own cities. Not a good thing, generally. So that's how that bit worked. This is the game infrastructure, so they'd all connect into the player access point, and then each team would have their own host, and then there was lots of attacking and defending going on between these hosts. And then the challenges, obviously, you need some challenges. It was tempting at first to just take vulnerable services off the internet, but then someone mentioned that you could just run Metasploit autopwn on the entire network and have everything straight away, which probably wasn't a good thing. So we wrote our own services that you could connect to with Netcat and then do interesting things with them. So this one had taken the VNC password and encrypted it using a broken RSA implementation, and then you had to decrypt it by, I think it was a padding oracle attack, if anyone's familiar with that. In that way. That's just an example of one of the challenges. Then we panicked because we didn't have enough challenges, and the scoring server didn't work, and the DEF CON bit didn't work. But eventually we got around to actually running the capture flag. So here's some pretty pictures of the knock. If anyone's ever seen Logstalgia, it gives you, it's like Pong but with Apache logs. So every request comes in as a little Pong thing. That was all of the websites being monitored for the entire network. And that is the DEF CON game display up the top being controlled. You can see lots of nukes being launched between there. It's quite fun. So taking a break aside from that, and that's the fun technical side of it, I'm going to move more onto the coaching side and why that's a good way of teaching security. And I'm going to do this from a whitewater kayaking perspective. That might sound a bit odd to start with. So I'm going to be honest, I don't have a PGCE, I'm not a psychologist or anything like that, I'm a uni student after all, but I do coach a lot of kayaking. So I throw myself down rivers like this in a fiberglass bit of fiberglass? Trying to think of a better word for it. It's good fun, but there's also an important coaching aspect to that, is teaching people to do a skill that they've never done before, which is what we're trying to do in cybersecurity. So, for relevance to this is a way we teach people, or a spectrum of teaching methods we use in kayaking. And I'm going to try and apply it now to different types of capture flags to try and explain the point. So the far left here, we have convergent teaching. And this is where you have one path to the objective. So you can start at any point, but you all funnel in towards one point, one solution. And that fits in quite well with your Jeopardy type capture flags. So you have generally one accepted way of doing it, you have your tools, you go through, back, and you get a flag. One answer. Then somewhere in the middle, so something called guided discovery is where you give them all different things to try, and they see which one works best. So with your attack defend, you're saying, go and attack these services and exploit them, but there's these different ways of doing it. And at the far end, the divergent, is where you start at a point and you say, I want you to get to this point, however you want to do it, or find as many different ways of going sideways as you can. And that's pretty much where we sat our capture the flag, in that their objective was to not lose population and keep their services up. How they did that, we didn't really care. Legal implications, obviously. But we didn't really care. So it was more mission-based than actually, here's your task, go and do it. And that's sort of where real life sits in that situation. Is you're not given, use these tools to do this, generally. It's, you have this mission, I don't really care how I did it. Get to the end point. So with that in mind, we had a separate challenge. Click. Nope. So there was a forensics challenge running alongside this, for which the mission was you had to suppress enemy air defences around this heavy water facility. Any coincidence is completely coincidental. And the missile launcher consisted of this. So we had a USB missile launcher from Amazon and a Raspberry Pi connected together. And this was completely air-gapped from the rest of the physical network. You had nothing into it, completely nothing. However, around the game network were scattered various breadcrumbs that you could take together, do the forensics on each one, extract information, and then build a USB payload that you could then put on that device to fire the missiles. So think Stuxnet, but with suppression of enemy air defences. So we have Convergent Challenge, which is the individual forensics ones. So standard steganography, file carving. This was hidden in a PowerPoint. I say hidden in a PowerPoint. You see the top secret information on the right-hand side about where the missile launcher could fire and where it couldn't. And then you took all of those together to get an overall divergent strategic aim. So in this instance, develop a USB payload. They'd give us a file, put it on the device, and then plug it in, and launch missiles away. And the physical effect was you'd fire missiles. If anyone's interested in how that worked, I can tell you afterwards. It was quite complicated getting it to work for some reason. So in terms of, we can take all of those and make some general principles about how capture the flag should be designed, how we operate them for best teaching effect. So a lot of CTFs focus a lot on the tools. So they're like, you need to use steg detect or whatever for this, or some particular tool for this. And focusing less on the tools gives you more opportunity to spread out and do it from first principles. Also, having missions or objectives is a good idea rather than specific tasks. So in industry, this is being done by SANS. They have a cyber city, which they're using as a kinetic demonstrator for cyber warfare, I think is the term. Does anyone notice the missile launcher similarity? And essentially, this is a model city being run using real PLC and SCADA devices. So the idea is your government comes in and they train on the PLCs and they derail the train or whatever. So actually here's the mission. So you have your mission, your cyber warriors have to derail the train to prevent the WMD getting to the other end. And you do that by getting into different systems, like turning off sensors, I think in this instance, and then breaking the control system. But it's a mission rather than a, you need to exploit this system, this system, this system. And that brings into the idea of having multiple different solution paths. So it's quite interesting from our CTF, analysing the data and looking at how many different ways there were of doing all the different things we said. And that's a really important part of learning, is finding your own unique way of doing things rather than conforming to a standard set. So in summary, capture the flags are really good for security training, probably the best way of doing it I've seen. But they could do more in terms of relevance for both physical and post-exploitation, moving beyond route as a concept, and also developing the training methodologies and the training science behind capture the flags. Hopefully you guys have plenty of novel CTF ideas where you're taking your favourite game and then linking it with a computer. And if you are part of a university, I'd be very interested in talking to you about moving this into universities, having different universities hacking different DEF programs. That's me done. Are there any questions?
In terms of what you were saying just now about other universities, is there actually any sort of programme in the UK, a CTF type programme, like CCDC?
No, there isn't, and that's a big failing. So I'm talking to the cybersecurity challenge guys. That's something they're really interested in getting started. But it needs money, and that's something not many people have nowadays. So we're almost trying to push that from a grassroots university, students getting in touch with different other bodies and trying to run that sort of thing. But that's something that isn't around at the moment, but we'd like to get around.
I spoke to CCDC a year, maybe 2 ago, and they said they would like to bring it to the UK, and then they went quiet. So I don't know whether it is coming or not. I'd love to see it over.
Anyone else? Thank you very much.
Sorry, got one quick question.
Last spell there.
Yeah, how were you? I mean, you were studying aeronautical engineering.
Yes.
So how were you able to have this happen? Because I mean, certainly from my experience at uni, I was studying engineering. It was very difficult to get access to the computer science people because they're very kind of siloed. So how did that happen?
So actually, I got in touch with those computer science people by going to a Detica Capture the Flag that they ran out at our university. So the team that I was in as part of that sort of went, this was really cool, let's run our own. And we split out of that as like a faction. And since then we've started a Facebook group, believe it or not, for interested people in security, and they just sort of flocked to it, so to speak. So that was how I, as an engineer, broke out of the mould traditionally to get into that side of it. But it is quite hard, and I'm quite interested in bringing this to engineering students and other. I don't know if I still have it. No. There was a subject breakdown of who was in it. It was quite interesting looking at the different subjects we had that weren't just computer science or electrical engineering. Because I think that's where it's failing really at universities, is they teach computer scientists security, but everyone else doesn't really get that at all.
Cool.
Okay.